Question number mixed exercise. Question number one. It's the motion of a cricket ball after it hits until it's land on the cricket pitch is model. Uh, the journey and h equal 1 over 10 24x minus 3x square, and x is this is h, the height, and this is x, this coordinate is xh. And question A, the vertical height of the ball when it is horizontal distance of 2 meter from it was hit. Just check that for just a test, when time is 0, x should be 0, then what is the h value? Is h is going to be 0? Yeah, h is 0. Yeah, h is 0. So the starting point is 0, 0, just to get an idea. Sometime it may not. I did double check. Horizontal distance when x equal 2. So we need to find the height when x equal to, we need h when x equal to. So h equal 1 over 10 times 24, 2 minus 3, 2 square. This is going to be 1 over 10, 48, 2 square 4, 4 times 3, 12. So this is going to be 36 over 10, that is 3.6. So this, when it is 2, this is going to be 3.6 meters. Part B, the two horizontal distance for which the height of the ball was 2.1 meters. So this is going to be 2.1. This height is 2.1 meter. This is also 2.1 meter. What will happen? We will get two x values. One is from here to here, other one is here to here. So we'll find when h equal 2.1, we need to find x. We'll substitute here 2.1 equal 1 over times 24x minus 3x square. So then this is become 20 equal 24x minus 3x square. Then this is 3x square minus 24x minus 21 equals 0. I can divide x square by 3. 8x minus 7 equal 0. So this is going to be x minus 1 and x minus 7. Something wrong. This is 20 and this is plus. That's right. Equal 0. X equal 1 or x equal 7. Those are the two answers. Part C, find the value of x for which the model is value. The model is valid while h greater than or equal to 0, because h is not valid for negative, h is not valid for the model. Then according to this one, what is h? H is 1 over 10. 24x minus 3x square has to be greater than or equal to 0. Then this is 24x minus 3x square greater than or equal to 0. I can divide by 3 because 3 is greater than 0 and 10 is greater than 0. That's why I multiply and make it 0. So this is going to be 8x minus 3, 8 minus x square greater than 0. Then 8 minus x greater than or equal to 0. So there are now we can see that 2 points. One is x equals 0 and other one is x equal 8. X times 8 minus x equals 0, x equals 0 or x equal 8. Now we know the answer. So this is the area that 0 to 8 is the model is valid. 0 greater than x greater than 8. Or sometimes we have to calculate it depending on the number of marks. So from here we identify 3 areas: 0 and 8 less than 0, x less than 0, 8 0 greater than x greater than 8x, and this bracket x times 8 minus x. This is going to be, if you select any negative value, this is negative, and this is negative times negative positive, multiplication is negative. So this is in here, you take value, this is positive, this is negative, sorry, this is positive and this is also positive, and as a result this is going to be positive. And if you take value more than that, this is positive, definitely this is going to be negative, and this is less than 0. This table you have to produce. Hence the model is valid for 0 greater than x greater than or equal to 8. Work out the maximum height of the cricket ball. Now we can do that one way by symmetricity. X value has to be by symmetricity. X should be equal to 4. Half of this distance, half of this interval, or we'll simply write differently. When x equal 4, the maximum will occur due to symmetry. So we will try to work this some 2 different ways. So h equal 1 over 10, 24 times 4 minus 3, 4 square, that is 1 over 10, that is 96. This is going to be 48, is 4.8. The maximum height is the maximum height is 4.8. So this is one method. The second one, h is 24 over 10x 3 over 10x square. dh over dt is 24 over 10 times 1, 3 over 10 times 2x. So dh over dt equals 0. We are going to find the stationary point. Then This is 24 over 10 minus 6 over 10 equal 0. Actually, we can cancel out 10. And then this is 6, 1, and this is 4. 4 minus um, x equal 0, x equal 4. So this is the uh, x coordinate of the stationary point. But we know by looking at this is a quadratic equation, then uh, since a less than 0, h has a maximum, then x equal 4 you will get a maximum. Hence now we can find h uh, equal 1 times 24 times 4 minus 3 4 square. We get the answer as 4.8. Or the other method is completing square. So from here you will take 8 out and minus 3 out. When you take minus 3 over 10, this is going to be minus 8x plus x square. So minus 3 over 10 x square minus 8x. So minus 3 over 10 x minus 4 square minus 16. So then minus 3 over 10 x minus 4 square plus 3 times 16 over 10. So this is the value. H is 3 times 16 over 10, that is 4.8. Question number 2. A diver dives from a diving board into a swimming pool with the depth of 4.5 meter. Swimming pool, diving board is here. So he jumps, person, and he jumps like this. This is going to be 4.5 meter. It was modeled 10 minus 0.58 x square. That's fine. So this has to be a maximum one. And the domain is given, the valid x value, valid x value. And find the height of the diver when x equal to. So this is the distance from the board, and h is the height. So this is going to be the coordinate xh. Find the height of the diver when x equal to a. When x equal to h equal 10 times 0.58 times 2 square, that is you will get 7.68. And part B, find the horizontal distance from the end of the diving board to the point where the diver enter the water. So we want to find this distance when h value is 0. We want to find the x. When the diver hits the water, h equal 0. So we'll solve this one. minus 0.58x square. I write this one first. Then plus 10 equal 0. Then actually x square equal 10 divided by 0.58 and x equal square root 10 divided by 58. So we will get the 17.24 square root, that is going to be 4. So approximately this value is 4.152. So this is going to be 4.1520. So x equal 4.152. So we have right here x equal 4.15 when the diver hit the water. Part C. In this model, the diver is modeled as a particle. Describe the effects of the modeling assumption. So then we have to write the particles assumptions. Then so air resistance is disregarded. Then the rotational effect of external forces are is disregarded. The other one, the mass mass of the diver is concentrated at a single point. RD. Comment on the value of this modeling assumption for the motion of the diver after she enter the water. So after she enter the water, two things will happen. One is the buoyancy, another like the air resistance, the water resistance. So the model is not valid as air, sorry, water resistance and act on the diver. We have a buoyancy for the upward force and the water resistance opposed to the moving direction. So if this is moving to this direction, so water resistance also there. Question number 3. Make a list of assumptions you might make create a simple model of the following. Part A. Motion of a man skiing down a snow-covered uh, slope. The motion of a man spinning down a snow-covered slope. So man is a particle. So what are the Usually we have 3 and covered with slope, snow covered slope. So snow covered slope, we can use smooth. Then we are expecting one thing to write here. So if it is a particle, uh, air resistance is disregarded and rotational effect of external forces is disregarded and mass is concentrated at single point. So those are the major thing. If you miss this one, still uh, you may get full marks. And the snow covered slope. This is a smooth slope. So friction is disregarded. Friction between skies and slope is disregarded. Part B, motion of a yo-yo string. So motion of a yo-yo on a string. So yo-yo, we can do a particle. So then air resistance. So this 1, 2, 3 will be here. 1, 2, 3, and the string. So we are using smooth, inextensible, smooth and inextensible. Smooth. Sorry, this is going to be light, not smooth. So mass is disregarded and inextensible. The more close idea is does not stretch. So the particle, so it should be the same 3 and is that all the motion of the skin down the snow. So snow covered slope. So this is uh, adjective to this word. So this is the thing that they are focusing on. So the friction. So sometimes you can see this kind of adjectives. Then it will help to trace the assumption. Question number 4, we want to convert into a, as usual, that 2.5 km a minute or 2.5 km 1 minute. So 2.5 times 1000 meter and 1 minute multiplied by 62 second. So it's going to be 41.7 ms minus 1. And part B 0.6 kg cm minus 2, that is 0.6 multiplied by 100 multiplied by 100, that is going to be times kg m minus 2, 6000 kg m minus 2, 0.6 kg cm minus 2, 0.6 kg over cm times cm, so c equal to 1 divided by 100 times 1 divided by 100, or 1 over 100 times 1 over 100, or 1 over 100 times 100, 0.6 times 100 times 100, 0.6 10 to the power 4, 6 10 to the power 3. Part C, 1.2 10 to the power 3 GCM minus 3. So 1.2 10 to the power 3 divided by 1000 multiplied by 100 times 100 times 100 times kg m minus 3. So 1.2 times 10 to the power 6. This is 10, 3, 10, 3 cancel out. kg m minus 3. So 1.2 10 to the power 3 divided by 1000 over 1 cm, 1 cm, 1 cm. This is 1.2 10 to the power 3 divided by 1000. This division, and 1 over 100 times 1 over 100 times 1 over 100, or 1.3 10 to the power 3 over 1 10 to the power 6. So 1.3 10 to the power 3 10 to the power 3 times 10 to the power 6. 1.2 10 to the power 6. Question number 5. A man throws a ball in a bowling alley. Make list of assumptions you might make. Create a simple model of the motion of the bowling ball. So that is A. Two things there I can see. Ball. This is going to be a particle. 3 assumptions. And alley. So smooth flow. Friction is 0. So you know the air resistance disregarded, and rotational forces disregarded, and mass concentrated in a single point. And part B, taking the direction of the ball travels the positive. Okay, assume it's going to this direction, positive. State with the reason whether each of the following likely to be positive or negative. So 1, velocity. So ball is going to this direction, and the positive direction also this direction. The velocity is positive. Then the acceleration. What is really happening when you throw a ball from here? That speed is getting lower and lower. So it means it is not acceleration, it is a deceleration. It is not acceleration, it is deceleration. Deceleration means negative acceleration. uh, negative. So acceleration is negative. Is negative. A train engine number 6 pulling truck start at station A, then travel into a straight line B, and then is move B to, so basically C A B C A B. Uh, what is the sign of the velocity of displacement on the journey from? So there are two things. A. So A to B, the velocity. Uh, so this is positive direction. Velocity is positive, and displacement negative. Sorry, positive. And then B to A, velocity is coming to this direction negative, and displacement still in the positive. And C, A to C, A to C is velocity still negative and displacement also negative. Starting point is A, so relative to A. So when it's got this time the velocity positive, displacement positive, still it is here displacement positive, but it is coming to this direction, velocity negative, and now it is here, it is going to the negative, so displacement plus negative direction, velocity also negative. Question number 7. Acceleration is given I minus a minus 0.05 I plus 0.15 J minus 2, so minus to this direction and 0.5 this direction. Uh, this is A. And the first question, magnitude. Uh, magnitude is mod A is minus 0 point square plus 0.15 square square root. That is going to be 0.025, which is 0.158 approximately. And part B, the direction of the acceleration makes switch to I. So I is here, and J is here. So we have to calculate this one. This is 0.05 this size. This size is 0.15. So we'll take this is theta, and we'll find tan theta first. Tan theta equal 0.5 over 0.05. That is 3. Theta equal tan inverse 3 is 71.6. Then this is the angle it's making. So let's say angle alpha. So alpha equal 180 minus theta, 180 minus 71.6, which is approximately 108.4. If you want, you can write this is I and J. Question number 8. V is 3.5. I minus 2.5 J. 3.5i, 3.5i, and minus 2.5j. So this is the direction of v, and find the speed. A speed, magnitude of v. So this is going to be mod v, 3.5 square plus 2.5 square minus square root. So this is going to be 18.5 is 4.30 ms minus 1. So part B, um, the angle of the direction of the toy car from G. So from G, this is I unit, this is 1G unit. So we need this one. I'll take this is alpha and this is alpha. So tan alpha I can write 3.5 over 2.5, which is 1.4. So alpha equal tan inverse 1.4. That is going to be 54.5. Now this is 54.5. This all is 180. I will take this angle is beta, the required angle. Then beta equal 180 minus alpha. So 180 minus 54.5 is going to be 126 approximately. This is for x direction and this is y. Question number 9. A plane flies from P to Q, and then from Q to R. So PQ is given. PQ vector is given that 100I plus 80J miles, and Q to R, QR given 50I minus 30J miles. Find the magnitude of the displacement of PR. So PR is PQ plus QR by triangle law. So PQ is 100I plus 80J plus 50I minus 30J. So this is 150I plus 50J. And we need the magnitude of the displacement. So we need mod PR, the magnitude of displacement, 150 square plus 50 square square root. (158) to the approximately. Part B, we need total distance, or we need distance to PQ plus distance to QR. It means mod PQ plus mod QR. So mod value is, this is going to be 100 square plus 80 square square root plus 50 square plus minus 30 square square root. So this value 164, 60,400 plus 3,400 square root. This is approximately 186. So part C, we want to find the angle of PQ with unit vector J. So this is X and Y, this is I and J unit vector. So 100I, 80J, 100I, and this is 80J. So we need from the J axis. So this is, I need beta. So I'll take, this is alpha. We'll find alpha first. Tan alpha equal so I can work actually beta straight. So beta, tan beta equal 100 divided by, because this is parallel, this is a z angle, those two are parallel. So tan beta equal 100 divided by 80, that is going to be 5 divided by 4. Beta equal tan inverse 5 divided by 4, that is going to be 51.3 approximately. So I need this one with vector j. So this is the j vector, this is minus j. Now this is the j vector, and this is the angle we need.